If you're looking for a video explaining what is new in Fluent Bit version 4, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the OpenTelemetry and Kubernetes series where we covered a lot of episodes. So several months ago, I have worked on a content explaining sampling and how tail sampling is the most precise sampling decisions with the OpenTelemetry data. During KubeCon Europe 2025 in London, the Fluent community released a fresh new release, the Fluent Bit version 4. And if you remember, in Fluent Bit version 3, they already had provided a lot of improvements related to the support of the traces and also on metrics by adding new processors to reduce the cardinality, be able to modify our attributes in our traces. But the version 3 did not provide any real features to process our traces. I mean, sampling. So the question, would this new release of Fluent Bit provide new features on the tracing side? So let's figure out with this episode. By the way, if you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what we're going to learn out of this episode. We'll start by looking at all the news, all the announcements done by the Fluent Bit community on the version 4. Then we will look deeply on each new processors that is provided by this new release. So the first one will be on the conditions that we can now make on our processor. So it's the conditional processors. Then we'll jump into the processor for traces, and I'm referring to sampling. We'll see that we have probabilistic sampling and tail sampling. And last, we'll share the latest benchmark results, compare the resource usage of Fluent Bit when using sampling. We'll compare it with the previous releases, and I'll also take advantage of those benchmarks to compare it with the collector to see if Fluent Bit is still as efficient in the resource usage. If you look at the announcement page from Fluent Bit on the version 4, there are lots of things listed in this release page. But what I can say is that the Fluent community has done lots of work to improve their OpenTelemetry support. I mean, for logs, Fluent Bit was already the best solution out there, and it has proven its efficiency, processing millions of logs while consuming just 15 megs and few millicores. I think no other agent as of now is able to achieve this. So when looking at this page, clearly the new processor build for traces, I mean sampling, is exactly what I was looking for from the Fluent Bit community. Having the options now to apply a sampling policy directly in Fluent Bit was something that was missing. So the probabilistic and tail sampling processor is just a fantastic news. Now I would say that there are still few features that are missing in Fluent Bit to fully use it for metrics and traces as well. On the feature missing, I would say metric conversion, the ability to convert metrics. That is crucial when you start dealing with different metric formats. I mean, Prometheus, StatsD, and others. Metrics and traces enrichments. Yes, they have added content modifier, but I was more thinking about Kubernetes environment with having the options to use their Kubernetes filter to add Kubernetes metadata to the traces and metrics. This is clearly missing for now, and that is a blocker. But instead of listing the missing features, let's cover what are the other announcements done in the version 4. Fluent Bit v4 comes with some really cool new stuff that makes handling our logs and traces so much easier and powerful. For logs, they have added a conditional processing, and in fact, it says logs, but I think it should also work in metrics and traces. I will try it out, and I will let you know from a LinkedIn post if it actually works on other signals. So basically, imagine being able to tell Fluent Bit, please process those logs if they contain error, or if the response time, let's say, is greater than 100 milliseconds. Improvements on the security side. They made it easier to configure TLS. You can now specify exactly which TLS versions and ciphers we could use, giving a tighter control over our communication. There are a few experimental features like the support of Zig programming language for plugins. This is pretty technical, but basically it means that developers now can create even faster and more reliable plugins for Fluent Bit, so easier to deliver them. And let's not forget about OpenTelemetry. Fluent Bit version 4 has significantly improved the support for OpenTelemetry protocol. This means it's better for receiving and sending all sorts of data through the OpenTelemetry protocol, so logs, metrics, and traces. So on the input side, the input plugin, they fixed some issues and handling gRPC data and added support for OpenTelemetry JSON traces. They also improved compression. They even put a limit on the message size to prevent problem with super large messages, meaning that we need now to control the size of our fields, avoiding to being cropped. On the output side, now it supports the compression ZSTD, which is a really efficient way of compressing the data to save some bandwidth. Finally, there's many other plugins that were updated, but the Kubernetes filter got a nice update. If you're running Fluent Bit in a Kubernetes environment, this is good news. It is now includes an owner references in our log record. When a log comes in, Fluent Bit can now tell us just not about the pod and metadata or annotation. It could also have a higher view on the Kubernetes resources like a deployment or a daemon set and who is owning that pod. This helps us to understand bigger pictures of our Kubernetes cluster and makes troubleshooting much more easier. So at the end, our log pipelines will be simpler by having those new extra fields in the Kubernetes filter. First, for those who have never heard about processors in Fluent Bit, then it means that you have not played with the latest improvement in Fluent Bit since the version 2. In Fluent Bit, our pipelines will go through various threads, so the input, then parser, filter allows the output to export the data. So parser and filter are technically all the plugins that was built since decades in Fluent Bit to cover the similar features that was available in Fluent D, meaning that filter and parser would be the plugins or steps that we would apply mainly for logs. Since then, the Fluent Bit community introduced the support for metrics and traces, and they started to add this notion of processor, allowing us to apply transformation to our data in the same thread as the input or output plugin. So basically, just when receive, do some transformation, or just before sending, do a final transformation. So the processor can only be utilized if you're transitioning to the new pipeline format. So it's transitioned from a table format now to a YAML format. I mean, if you want to take advantage, of course, of all the latest features introduced by the Fluent community, then yeah, transition. Otherwise, you will stay in the past. Anyway, as you know, when dealing with logs, you can process them in various ways using the traditional filter and parser or using processor, and especially the content modifier processor. With Fluent Bit version 4, they have introduced a new options allowing us to define a condition to the operation that we would like to apply on the logs. Fluent Bit is relying on this concept in the past of tag. So when we receive, you put a tag, and then once you apply a filter or a parser, you say, you match that tag, then you do that operation. So tag were there to basically help us to apply specific sets of filter or parser plugins on specific tags. So tags was an amazing way to define the type of data that was targeted by a set of operations. But in processor, it is a different story. Processor, remember, are attached to input or output plugins. Of course, you can define tags on the input or output, but all the steps defined in the processor would be applied for these steps, for this input or this output. So now the conditional processor is here to help us. The conditional processor is technically not a new processor, but an extra option to existing processors. For example, to apply a condition on content modifier, I can do this type of design. Here, I have a log processor, I do an insert, let's say a key alert, I give it a value, and here I make a condition. So conditions define when this content modifier action would be applied depending on the content. Conditions requires to define one operator, so op, and a set of rules. Op can be either equal to and or simply or. So if you have only one rule defined in this condition, then you will have to set it to end. Then you need to define your actual rules in the rule sections. You can have several rules defined in the rule sections. Each rule will define which field we are targeting, the type of condition operator, and last, the actual value that we want to. So fields, you can understand, will reference to one of the fields available in our logs or potentially metrics or traces. And this is where we're going to apply these specific conditions. Op supports for the condition operator, supports different type of operations. So you can have equal, not equal, greater, greater than, blah, blah, blah. Also, you can also use regexp to match an irregular expressions, or not regexp to not match a specific irregular expressions, and in or not in. So let's say we want to flag our log by adding a new attribute called source. For example, the logs coming from envoy will have the source equal to envoy, traffic called traffic, inspector gadget, and so on. So we can then use the content modifier processor that will insert this new attribute source, and the value will depend, of course, on the conditions that we have defined. The sampling processor is the most exciting feature of Fluent Bit version 4 because at the end, it is adding one of the most important features when dealing with distributed traces. If you never heard about sampling, check the following episode explaining all the secret sauce about sampling. But to make it short, sampling is a required step when dealing with traces. I mean, sending 100% of distributed tracing does not make sense for the storage perspective and moreover for the costs perspective. We need to keep the traces that will reflect our production activities and help us to troubleshoot issues in our production environment. To achieve this, we could sample our trace in various ways. But when sending our data to any Observability backend, we expect to have the options to create sampling decisions smart enough to get the right samples of data. The sampling processor requires to define the type, defining the sampling algorithm that we would like to apply. And in Fluent Bit, there are two types of sampling. So we have probabilistic sampling, and the second one, and I honestly prefer this one, it's tail sampling. To be clear, with probabilistic sampling, Fluent Bit is not providing a consistent probabilistic sampling like the collector, but a traditional probabilistic sampling. So similar to like a head sampling trace ID ratio. Meaning that Fluent Bit will apply a ratio to the incoming spans, so it will reduce the volume, but it won't guarantee a consistent sampling decision across our traces. Last, it is not adding any flag to our trace context with the actual sampling decision made by Fluent Bit. Meaning that if we extract, let's say, 20% of our traffic, then our Observability backend will inject that data, will produce stats from the data, like the error rate, the response times, the throughput, the endpoint, without, in fact, actually knowing how the data has been sampled. So if you send a random 20% of traces, then this stats will be completely extrapolated. You will have a nice graph, but you have no clue of what they actually means or actually represent related to your traffic. So I would clearly never use this sampling algorithm when using Fluent Bit. The probabilistic sampling of the OpenTelemetry Collector is more advanced. So if you're planning to use probabilistic sampling, then I would recommend to use the OpenTelemetry Collector. Anyway, the probabilistic sampling is fairly simple. The probabilistic sampling required one setting, sampling decisions that will have one property, sampling percentage, defining the sampling ratio that we would like to apply to our spans. Then you have the other mode, and that I personally prefer and recommend. It's tail, like tail sampling. Unlike head sampling, the decisions to keep or drop a span requires to store the entire trace, so all the spans. This will mean that Fluent Bit will need to store all those spans in memory and then apply the sampling decisions that we have defined. So we would expect an impact in memory usage of Fluent Bit. But we will see that in details in the benchmarking result to see the actual consumptions of the tail sampling. Similar to the collector, Fluent Bit will allow us to define rules based on the latency, so on response times, the trace state, to see if we have any errors or not, the size of our traces, and last, on conditions on attributes that are in our trace. All the rules will be defined under the field conditions, so we will need to define as many rules as we want, and if any of the rules match, then our trace will be sampled. Each condition rule will need a type and the right settings related to the type. So the type will define where we would like to apply these conditions. There are several available types, like I mentioned. So latency, this rule lets you to sample a trace based on how long they took. So perfect to collect slow transactions or remove the one that are completely above the thresholds that we defined. This is a goal for spotting performance bottlenecks and making sure critical operations are basically sampled. So we have two settings. So it's the boundary at the end. So thresholds milliseconds low and thresholds millisecond high to define the min and max boundary for the response time. Then we have span count. This condition lets you to filter based on how many spans are actually in the trace. For example, you might only care about traces with a certain number of spans, okay, between 3 and let's say 20 or 5 or whatever, to perhaps dig into more complex workflow or filter out very short processes that just gonna be noise in our systems. So you need to define two boundaries, so the min spans and the max span. Status codes, here is basically to be able to filter on the status of our traces, basically to target only the traces in error. So we'll use status code, and that is an array, and you can put all the status codes that you are interested in. Trace state, this is for more advanced situation. The sampling processor can even sample based on the metadata in the W3C trace state field, meaning if you have a component that is running probabilistic consistent sampling, you could extract the fields out from the trace state and make a condition about it. Otherwise, if a vendor agent or something similar is adding a specific field in the trace state, you can take advantage of it to make a condition on it. Then you have all the conditions related to the attributes, so the string attributes. This will create a condition based on attributes holding a string value. For example, we could sample all the methods that are posts. The string attribute has a field or a settings called match type. There's two available values for match type. So strict, meaning that it's going to be equal to the value. So we'll have to define the value field, and there is exists that will just check that this attribute exists in our spans. Numeric attributes, so it's similar to the string. We'll make a rule about an attribute that is numerical. Here, the match type could be strict, or we can define a range of value. So very useful if we say we want to report all the SAP status codes that are between 400 and 504 or whatever. So for example, here we can use a specific range like this. We have the Boolean attribute. Same thing here. It makes sense to define a condition based on an attribute that is a Boolean, and here we'll have to define the actual values, true or false. For example, if you would like to sample all the traces in error, traces that are, let's say, above 100 milliseconds, and then the one that has SAP status code between 400 or 404, or maybe a specific priority flag that is holding to attribute, we could define the following processor within our Fluent Bit. When defining tail sampling, it is also critical to define the sampling decision property. And here we will define the timeout. So how long we're going to wait to get the actual trace, and how many seconds that should Fluent Bit wait until applying the sampling decisions to our trace. And of course, the other parameter which is important is the max traces stored in memory. By default, by the way, the wait time is set to 30 seconds. So depending on your business process, you should probably adjust these settings to avoid eating too much memory because at the end, tail sampling is going to be very expensive in resource consumptions. Small remark related to sampling. Maybe it's obvious, but when doing tail sampling, Fluent Bit needs to have all the spans of a given trace in the same instance. Otherwise, the sampling decisions will be a bit strange. That is the reason we cannot use our traditional daemon set deployment of Fluent Bit for sampling, but we'll have to use a deployment or a stateful set. Very important. And one other important note is that we cannot have several replica because simple, Fluent Bit does not have any output plugin doing the load balancing based on the trace ID. So if you do several replica, you're not sure to have all the spans of a given trace on the same instance. That's why use, for now, one replica of Fluent Bit that will receive all your traces, and this one will be responsible of applying your tail sampling decisions. To run this benchmark, I'm using the similar infrastructure that I have prepared for the episode comparing Fluent Bit against the OpenTelemetry Collector. So for this, I will have the OpenTelemetry demo with Istio deployed. Why Istio? Simple. I want to produce more logs and more metrics and have Envoy producing spans. So I would have one spans produced for the incoming request and one spans for the outgoing request for each Envoy proxy, which means you have 20 microservices, which means I'm gonna add more spans in every transaction produced on the OpenTelemetry demo. Next, I'm deploying Kepler, that is an expensive exporter, and a couple of other Prometheus exporter. I'll run 2 instances of Fluent Bit, like explained before, one collecting logs deployed as a daemon set, and one collecting metrics and traces deployed as a deployment. And this one would have tail sampling configured for 2 input plugins, so the OTel HTTP and the other one, OTel gRPC. The tail sampling would cover the latency, so everything that is above 100 milliseconds, every error code from a span perspective, and finally, I will have some numeric attributes rules to check the HTTP response code and the gRPC response code. So let's start comparing the memory usage on the CPU and memory side related to Fluent Bit, and measure, in fact, the impact of sampling on our Fluent Bit instances. So the traditional Fluent Bit, not doing any sampling, consumes usually around 15 megs and few millicores. But we can see here clearly an increase of the CPU and the memory usage. In the CPU side, it's quite stable over time, but we can see that it has an increase of about 250% extra resources compared to the normal Fluent Bit instance. But at the end, it's still acceptable because it's about 0.10 millicore. The most surprising thing is about the memory usage. So you remember, normally we are consuming about 15 megs and very stable. And here, the memory keeps increasing over time, almost reaching 1 gig of consumptions. And I think with a stable load and having the memory keeping increasing, I suspect clearly a memory leak here. Now let's have a look at Fluent Bit versus the collector. So here I'm using a dedicated collector for sampling, having the similar rules defined. And it is going to be a big surprise. I mean, I was very surprised when I look at the numbers. Fluent Bit used to be a champion in resource utilizations, and here it's clearly the opposite. The collector memory usage is super stable over time when doing sampling, and it's basically, it's reflects what we were expected, consume around 80 megs to 90 megs. While Fluent Bit usage here is flying on the roof and is just keeping increasing over time. Even on the CPU side, Fluent Bit is consuming almost 4 times more CPU than the collector, but again, nothing alarming because it's still acceptable in terms of resource utilizations. Again, here I think there's a defect, a problem with the memory leak, so we cannot blame the project on this. I have opened an issue related to this, so let's cross the fingers that this will resolve quite soon, and then we can rerun some tests to confirm that the Fluent Bit is still a great agent when it comes to resource utilizations. Fluent Bit is clearly moving towards the right direction. it still misses few processors and for metrics and traces to fully use it for all of our signal. Especially, I'm referring to the ability to enrich metrics and traces with Kubernetes attributes, or even resource detectors to add attributes related to the host, the operating systems of the server. The other big thing that is still missing is metric conversion. I mean, if you're dealing with metrics, you will probably have to convert them in any way. In fact, in my benchmark, I had to use a specific collector only for metric conversion. So it still shows a big limitations on the metric size. Otherwise, like expected, the resource usage was significantly impacted by sampling. I was not surprised on this, but what surprised me the most was the memory usage of Fluent Bit on tail sampling. For now, I clearly suspect a memory leak. So if you're using Fluent Bit for sampling, well, use proper machines for that. But from a test on comparing the collector versus Fluent Bit, I think collector seems to be a more reliable for now on sampling side in terms of features and resource utilizations. And more important, Fluent Bit is not providing us a load balancer exporter to load balance data across several instances of Fluent Bit. And when you deal with sampling, when you know that sampling is going to be very tough in terms of memory consumptions, you may want to have the options to load balance the sampling in various instances of Fluent Bit, and this load balancing policy will be done on the trace ID. Other thing that could also be improved when adding sampling or other processors in Fluent Bit is basically have more metrics. I mean, as of now, the Fluent Bit metrics is limited to the input, filter, parser, and output plugins. So at the end, the logs perspective. So measuring the actual sampling ratio is not possible, or even measure the number of data coming through or flying through one of the processors. We have no clue. So adding that telemetry, extra telemetry will be more than welcome, especially if we manage lots of Fluent Bit instances. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.